Hello, good morning and good evening, considering to your time zone. Today, I really want to talk about a powerful tool from Flow Cytometry. I want to talk about a t-SNE. I assume this is the right pronunciation, t-SNE, t-SNE. So we all know that flow cytometry generates very high dimensional data, and sometimes it's really difficult to analyze this complexity from these data sets, and Disney is actually help us to analyze and visualize these high dimensional data sets by reducing its dimensions into 2 or 3 dimensions. So Disney actually captured the complex relationships between cell based on their marker expressions and clustering them in a way that reveals underlying biological insights. So by applying t-SNE in flow cytometry data, we really can identify distinct cells populations that are rare or even difficult to differentiate using other traditional analytical tools or methods. So in summary, t-SNE in flow cytometry, we can identify distinct cell populations. It's not just a visualization tool, it's a tool we can use to get way to deeper insight into cellular heterogeneity and functions. And the application of t-SNE can be used for cancer research and immunotherapy and beyond other sector of research. So I already have a one analysis you are seeing, but I want to show from you the beginning. So I want to go. So you know how to load your data sets in FlowJo. So I will consider this is my FlowJo data set. This is a really simple example to do the t-SNE. Probably you may have a lot of complex data sets which you can analyze, but my idea is to here just to show you how you can start and you will be expert based on your experiment. So this is one of the experiments here. I will start with gating. So considering these, I will be strict and I'll get this as my lymphocytes. And the second thing I will do, I will find out the singlet. So you know the singlet is for scatter area and for scatter height, or side scatter area and side scatter height. So here is my for scatter height versus for scatter area, which giving me singlet. Let me get on that. So this is my single cells, and then I'll go for the live and date. So this is my, I guess I took the wrong dongle. So this is my live cells. I'll just modify this gate. Okay, now it's look fine. So these are my live cells, and from my live cells, I'll go for my T cells or CD3. So these are my CD3 cells. So I'll just name CD3 positive cells. So now I did my gating and you'll see that my gating is here. I started with lymphocytes. I gated to single cells and then I nulled out the dead cells. And from my live cells, I have CD3 positive cells. Now I'll go for the t-SNE. So in your FlowJo under workspace, you'll see a option t-SNE. So first of all, you have to select a CD3 positive since you want to do or apply the t-SNE based on the CD3. So select CD3 and then press t-SNE. So when you'll press, probably you'll find this automated highlighted option. So it's always better you go with the compensated data sets. So you'll find this window with already selected option. So here I already nulled out live cells and dead cells. So I'll just remove this dead cells option. So I'll just press Ctrl and press dead to unselect dead. And I already have a CD3 gated, so I'll also remove the CD3. So here you'll find a few options which I will try to talk very brief before I do the t-SNE, but I'll just do really quick for now, and I'll come back here to explain what I am doing or what I'm just why I did that. Because when you start t-SNE, it takes time to complete the analysis and algorithm and to get the data. So you see that I selected something which I will explain, and it started calculating. So it will take few minutes. The more complex data sets, the more populations you will work on that, the more complex it will be, and it will take more time. So let give this computer to analyze, and then I will go the analysis options to explain one by one. So here you can, if you really don't know what option to choose, you can just go by default, because the FlowJo is very good way to optimize, and it can run really 10 times faster compared to other analytical tool. And of course you can trust this data and the results. And I guess I can easily do 1 millions of events. However, the new FlowJo versions, later than FlowJo 19, you can do up to 5 millions of events. So number is not just a hindrance here. So you can leave, as I said, the parameter as it is, like iteration, perplexity, and learning rate. However, as I promised, I'll go really quick each of these options and give you very brief. So first one is the learning configuration, which is one. First one is the auto one. So auto one is really faster than the manual one. And again, if your cells population is less than 1 million, you really don't wanna choose the manual. The auto would be really fine. And typically people go with this auto one. And to be honest, it doesn't make a very big difference if you have a less than 1 millions of cells. So select auto, which also faster. It will get your analysis a little bit faster compared to manual. So the iteration, which is you can like select these reference, you will get all the explanations of each term, but I'll just give you a very quick idea. So iteration is actually defines the maximum number of times the algorithm will run. So typically people set iterations 300 to 3000. So the FlowJo, I am doing analysis 1000, which is a very good number. So if you set the number is more, like say if you set 2000 or 3000, then it will take more time to complete the analysis. As I said, it's the iteration is the maximum number of times the algorithm will run. So I'll set 1000 here, and the next one is the perplexity. And perplexity actually determines the number of nearest neighbor considering in this algorithm. It influenced the data density interpretations, and usually we set 2 to 100, and I just said 30. And the next one is the learning rate, or ETA, which actually controls the step size for gradient descent to minimize probability differences. Values between 2 to 2000 are typical. And you can use the other thumb rule, like you can consider that 7% of your populations, or 6%, 5% of your populations. So in different way you can calculate what is the highest number of populations you have, and what is the 5% of your populations, and you can just add this number. So for today, to show you the analysis, as I said, you can go 2 to 2000. So I'll just set minimum number, not minimum, like 2000 um, here, to see or to complete this analysis very short. And the next one is the KNN algorithm. Again, it's a very mathematical term. You can study very details, and if you really don't know or don't want to study, it's fine, because as I said again, if your cell number is less than 5 millions, it doesn't make very big difference or no difference at all. But you have a two option here. One is the exact, and another one is the approximate NI. So usually, I would recommend to go with approximate. It will save your analysis time, and you will get the pretty much or exact same results compared to the exact options. So I'll choose the NI one. And the next one is the gradient one, or gradient algorithm. The gradient algorithm adjusts the data embedding from high dimensional to low dimensional space. So the one option is Barnes Hart option, and another option is the FTD, which is a first Fourier transformation interpolation. Sorry, first Fourier transform interpolations. So again, I would tell you the same thing. If you have less than 5 million cells, if you have a 1 millions of cells, it doesn't matter. The FTD would probably again give you results shorter time, and you'll just run this, just hitting the run, and just make you can change the name in the, if you want. Let's see how much is our job done. So I didn't hit run since I already did initially, and I see this is my results. Sorry, I'll close this, and this is my results. Okay, this is a very beautiful results I have here. So your t-SNE plot is here, and if you press this date, you cannot select. So initially it can give you panic. Don't be panicked that you cannot change the populations. So to change the population, you have to select the color axis, and now you see that color axis and color code, and you can easily familiarize yourself that what this color means. Is start from blue to red. So now you can actually go here and you can change the populations you want to see. Say I want to see the populations of CD8. So now I know my CD8 population is left side bottom portions, the below portion. I cannot explain you probably nice way, but you see the the yellow side compared to the green one is your CD8, and you can actually play with this marker, and you want to see CD4. So you can see the beautiful CD4 populations in yellow. So you know the rest of the analysis, how you can print it or how you can analyze it. Uh, so I'll just select these, and I'll just right click and copy to layout editor. I'll just make a new layout. So this is my new layout. I'll copy again new, and you just have to change the CD4, CD8, and drag it here. And if you want to see your interferon, the same way you'll just copy and put in the layout. And the last one I want to show, you know that you can play with all the parameter, but I'm just showing you how you can start. So that's it. That's a quick start to analyze t-SNE. Um, you know how to play with this software. You will find a lot of videos on internet. So this is the simplest way we can do t-SNE. If you have question, you can ask me, or you can search in the Google or watch more videos. I hope it helps. Thank you for listening.